Hi friends, so in this video we are going to learn about stack data structure. So till now we have seen about linked list. Now we are going to learn about a new type of data structure that is called stack, or you might be knowing this data structure by LIFO or FIFO, that is last in first out or first in last out. Now what is in this video we are going to learn about what is the need of this data structure known as stack and why it is known as LIFO, or sometimes it may be known as FIFO, FIFO, that is last in first out or first in last out. So why there is a need of this new type of data structure and why it is known by these two names, this we are going to learn about in this video. So stack is basically a data structure. We are currently learning about the different types of data structure and the various operations that can be performed on them. But why do we need this new kind of data structure? So this data structure is used to store the elements. Okay, so basically we are storing the elements but with a restriction. Okay, and what is this restriction that we need to implement? This restriction is that elements will be either inserted or deleted at the top. Like there will be a restriction that elements that is inserted last. Okay, so elements that is inserted last will be deleted first. Okay, so last insertion, first deletion. Okay, or in other words you can say that elements that is inserted first is deleted last. Okay, so this is the restriction that we impose while we insert the elements or store the elements in the stack data structure. Okay, now this restriction, why is it needed? We will learn in the applications of stack. Why do we need stack? Because when we talk about the applications, then we learn why do we need this restriction, that is last in first out or first in last out. Okay, so these restriction would be clear in the application. First, let's learn about how the elements are inserted and deleted. So two common operations that we are talking about. First is insertion. Okay, so the insertion order and the deletion order would be just opposite to each other. Okay, so inserted first, deleted last, and inserted last, deleted first. Okay, so insertion and deletion are done from the same end. Okay, this is very important that insertion and deletion are done from the same end, right? And these end that from where we insert or delete is known as generally known as top. Okay, so like this. Now let's look at the structure of this stack. So it will be something like this. Okay, and here we have this top. So we insert, let's say we start inserting. First we insert A, then we increment the top to this, and now this part is empty. Again we inserted B, we increment the top to this position, and again we inserted this C. Again we incremented the top to this position, then we inserted D. Again we our top is incremented to here, and so on it will be done. Okay, so this is basically the insertion order. So the insertion order would be first we inserted A, then we inserted B, then we inserted C, D, and E. Okay, in this order. But if we start deleting the elements, so first we will get the top. Okay, as I said that insertion and deletion always happens with one end, from one end, and with that end is known as top. So the top here points to E. So if we check off the deletion order for these elements, so it will be first we start deleting with the E, then we deleted D, then C, because the tops goes on decrementing. Okay, and lastly we deleted A. Now we are left with no elements, so we will come out of that. Okay, so see, the insertion order and the deletion order are just reverse of each other. So this is stack, where we have to insert or delete with the same end. Okay, so if you name it as index, it will be starting from 0 and it will be 4. Okay, so this is basically the function of stack. Okay, so we will be learning more of that. But let's see, the new element that is inserted every time here is done with the help of top. And of course, if we start deleting also, so we start from the topmost element is deleted first. Okay, so this is why this top is very important. Now we have learned how this restriction and all, and how we are storing element with restriction. But where do we need this stack? I mean, we can't do this. Why do we need stack actually? Okay, so the question is, why do we need stack when we already have this arrays and linked list and other data structure? Why this new data structure is needed? Okay, so if we look at the applications of stack, then this point might be made clear with that. Okay, so what are the applications of stack? Okay, so let's learn about those. So the very first application is recursive function calls. Okay, recursive function call. We will be dealing with each example and in separate videos, where we will learn why stack is required for this kind of application. So for the very first application is recursive function calls can be implemented with the help of stack. Okay, why? Because let's say we have one function func A, inside that we have another function func B, then we have another function inside func C, and then again we have one more function func D, right? And there is a code for something like that. Okay, and then this ends as if. Okay, so if this func A is called, if we need to call func A, okay, so the very first time we start calling func A, then these whole functions will be called simultaneously, like this func. Okay, so inside we entered and there is func B. So func B won't be called automatically, right? So we are in func A, then we have func B, then we have func C, and then D, and so on. But what will happen if we have this recursive function call? Let's say if we have one function, let's not worry about this. If we have one function like the Fibonacci series, or let's say we are calculating the factorial. Okay, so when we have the factorial function here, okay, so we have the factorial and we are passing, we have to calculate the factorial for the n. Okay, and let's say the return type would be int, and we are comparing first that if n equal to 1, we are returning n. Okay, else if n equal to 2, or let's say else if n equal to or less than equal to 0, then also we have one condition. Okay, like this. Let's say it's not factorial, else we are returning something like fact return fact of n into fact of n minus 1, something like this. Okay, okay, it got confused. Uh, return n into a fact of n minus 1. Let's say this would be a function. Uh, Now, if we call the factor 5, okay, we call fact of 5. So it will, if n is not equal to 1, definitely. So it will be calling this else part. So it will return something 5 into fact of 4. It will return this 4 into fact of 3. Okay. Then it will be returning 3 into fact of 2, and it will be returning 2 into fact of 1, and since n equal to 1, we are returning 1. Okay, so this function returns 1. So the very it goes like a stack. Okay, so if we consider here stack, so first we have we are calling fact of 5. Then what we are doing n into fact of 4. We are calling sorry, we are calling fact of 4. Okay, this is just the return type. So here we are storing the functions, okay, in the stack. So let's say it returns n into fact of 4. So now this fact of 4 will be coming here, fact of 4. Okay, again we are returning n into fact of 3. So this fact of 3 will be called, right? Instead of n, write 5, here 4, and now this fact of 3 will be returning something called 3 into fact of 2. Okay, this will be stored here somewhere, and then it will be fact of 2 and then fact of 1, right? So in this way, the insertion of functions will be happening in the stack. This is the very first inserted function. However, the calculation would be done from here. Like first fact of 1 will be reduced to 1. Then this 1 will be popped out, and after that this part will be calculated. So 1, so this will be 2 into fact of 2, right? So this part will be evaluated to 2 into 1, that is 2. Then our top will move to this position. Then this part will be evaluated to 3 into fact of 2, that is 2. Okay, so 6 and so on. So we will be more discussing about this how it happens, but ultimately we will be reduced to this part. So you see that we are storing the, for the recursive function calls, we are storing the first function at the bottom of the stack, then the second called function at the second level, and so on. However, the last inserted function is calculated first here. Okay, so this is why we need a LIFO kind of structure, so that the last entered is calculated, is the first out. Okay, so we will learn more about that in the upcoming videos. It's just the basic introduction of why do we need a stack, for what kind of implementation we need a stack. Okay, the second implementation could be matching the HTML or XML tags. Okay, so if we have XML tags or HTML tags, we need a stack, right? If we need to match them. For example, if we have something like a tag like this, and inside that, so we don't have this ending like that. So we will be having something like it's starting from one tag. Okay, and within one tag we have another tag, and then we have another tag, like so on. Okay, or else we can consider something like this, parenthesis. Okay, now we need to check whether this parenthesis is a valid parenthesis or not. So in that way we can have the stack, and we will start putting these parentheses as such. Okay, and this way, and once we have parsed all the parentheses from here to here, like our parentheses are ending, so we start popping. And if we start popping, then we need to pop accordingly. Like if we have this parenthesis, so we will be doing the popping as such, like for each right parenthesis we need to have one left parenthesis, right? So in this way, we can configure. It will not be the exact implementation. For example, it will be like something like okay, let's learn if something is like that. If we start traversing, so we have this left right parenthesis, and then we have this opening parenthesis, and for each opening parenthesis we will insert this into the stack. Okay, this is opening parenthesis. So for each opening parenthesis, we are inserting that into the stack. And once we encounter the closing parenthesis, for example, we inserted three opening parentheses like this. And once we encounter this closing parenthesis, we start popping. So this is the first encountered closing parenthesis. So we will, our top will be pointing to this position. So we start popping this. So for each closing parenthesis, we pop one opening parenthesis. Okay, and so on. If at the bottom we are left with no parenthesis, I mean we are left with no elements, our top points to -1 or so, then definitely there is a match, and it is a valid parenthesis. Okay, so like that we can check whether it is a matching tag or not for XML or HTML. Next, we are coming up to this. So this balancing parenthesis could be one example. Balancing parenthesis or balancing tags. So this could be one of the application or example of why we are using the stack. So this thing can be implemented with the help of stack very easily, right? If we want to check that our parentheses are balancing or not, because here we had six symbols, but if you have a large operations or a large expression, then definitely you need to balance the parentheses, and for that you need this kind of data structure, so that you can just assume that the parenthesis is valid or not. Okay, so this balancing parenthesis and matching XML or HTML tags are similar to each other. So this is why we need this stack. Very useful application for stacks. Okay, next coming up in the list is uh, infix and infix to postfix evaluation. Infix, this is one topic we need to learn. I'll be discussing about this in more detail in a video. So infix to postfix conversion, okay, and postfix evaluation. Postfix evaluation. This is a very important part of the stack application. So we will be covering up in one video for this part. So we start with infix expression. Infix is simple like 3 plus 2. We convert it into postfix expression 3 2 plus, and then we evaluate this operation, I mean expression. So this is also very important part of the stack application. Why do we need this stack data structure for evaluating this? Okay, so this is important. And next application is towers of Hanoi problem. So towers of Hanoi. So it is this problem you would have seen somewhere, like we have two towers, and we have plates, and there was a movement, so that we like there is some restriction. So this is a kind of problem situation we will be covering up in the next video. And then we have the Fibonacci series. Okay, so for this also we is one of the important application of the stack. Okay, so another example is undo and redo operations. That is the most commonly performed operation in computer. So these are some of the examples of or applications of why do we need the stack data structure. So we will be looking at some of these in the upcoming videos and in a more elaborate way. Before that, we will learn about the stack, the ADT, and also what kind of operations we can perform on stacks and how we can implement stack with the help of array. Okay, so till that, keep watching this and thank you very much. Bye.